In this video we're going to be looking at a toaster, standard 2-slice toaster. This one's made by Kenwood. I've already taken it apart, but I've just put the cover on to show you something. It's got the problem where if I push this down it won't stay down and it just pops back up. First, a note on how to get into the thing. You have to remove 6 screws underneath the base. Now, annoyingly, these have security type screws which don't have a normal head, so I had to fashion a screwdriver with a slot in it so that they could fit in. That was quite easy. Take an old screwdriver and hacksaw a slot in it. Then you can remove the bottom. Then also the knob here I had to hacksaw off because I found there was no other way. I couldn't slide this knob off, so I had to hacksaw off the ends. It had a little bulb here. So if we take this off, we've got access to the toaster mechanism underneath. Then what I did was I removed the circuit board, and also this is the slider to adjust the timing, just so that I could get better access to things. And these were screwed into the container. So now let me demonstrate the fault. I'm going to plug it in. Obviously, got to be careful. 240 volts. I take the toaster and push it down. Now, I don't know if you can hear that, but the toaster element, both elements come on, and there's a lot of heat, but it just springs back up. So that's significant, that the elements both come on, but the toaster won't latch down. I'll just turn off. Now, why is that? Now, there can't be, if I just turn the toaster on its side, there isn't any mechanical problem because we know it turns on. So the problem is to do with this latching mechanism, which is powered by an electromagnet which pulls this iron piece and latches the toaster down, as explained in many other YouTube videos. So the problem, so let me just go over that quickly. There's the switch operating here, and that is operating correctly, and power is getting to the elements. Now, what can we check? If we look, if I again turn it on its side, got the this is the circuit board which is controlling the timing, and it is plugged in here, and here's the adjuster. So the question is there any power getting to the circuit board? And if we can establish that, then we know there's something wrong with the circuit board. So what I'm going to do is I'm going to disconnect the circuit board here, like that, and I'm going to measure voltage. Now we can see there's a feed from the red wire and a feed from the blue wire, and these correspond to your connections of red and blue, of live and neutral. But this is tapped off from the element. In other words, if I look down here, I can see that that red wire, I don't know if you can see that in there, is connected by a bolt at a certain point down the element. In other words, what we've got is this. We've got power coming in on the brown and the blue, and the switch, which we know is working, which is powering the element that heats up. Now I've just simplified it to have just one element. And then there's a red wire coming from a certain point along the element, and there's also a blue wire connected here, which is tapping off power to the circuit board. So now we want to check what that power is. Then there's also two green wires, and they go to the electromagnet. So the circuit board must be determining how long the electromagnet stays on for. So first thing we want to do is check what's the power between the red and the blue. So now what I've done is I've stuck a couple of bits of wire in the connector to make it easier, and connected crocodile clips to the voltmeter. So now if we plug it in, turn on, obviously got to be careful as always because this is high voltage, press this down, we don't see any reading. That's because I've got the voltmeter set to DC. We need to turn it to AC. Try it again. And we can see we're getting about 20 volts RMS. So now we know there's voltage going to the circuit board. Is the circuit board outputting voltage to the electromagnet? We would expect not, because it's not latching it down, but let's confirm that. So I've plugged it back in. Now this is going to be slightly more tricky because I need 3 hands. I'm going to measure the voltage here. There is not an easy way to get it on the electromagnet there. So I'm going to measure it between here and here, which corresponds to the inputs on the connector. Now I've just found this bit of rubber exactly is the right, I've turned it off by the way, is exactly the right height to go in there and create a connection. So if we put that in there and then try and measure the voltage, let's see what we get. So I'll plug in, turn on, and it's a little bit tricky here, but let's see if we can see if there's any voltage. Nothing. Just confirm that we're getting the 20 volts. There's the 20 volts, but we're getting nothing on the green as expected because that electromagnet is not powering on. So we know there's something wrong with this circuit board. Right, I've removed the the circuit board. So we know power comes in on the red. So let's just trace where that goes to. That corresponds to here. So the first component is this big resistor. So what I'm going to do is I'm going to measure the resistance of this and see what it is. So let's set the meter to resistance. See if you can see that. Make sure you can see that. And let's see what the resistance is. Well, that's showing open circuit. Let me just check on a bigger scale. That's showing open circuit. Could it be that the first thing I look at from this has failed? It's possible. So what I'm going to do is desolder that component and check its resistance out of circuit. Because from that, it's open circuit. So now we have the resistor out. Let's check just to see. Still open circuit. So amazingly, the first component that we test has failed. Now, if you look at the board, and I'll just zoom in here. If I just turn that around the other way, I don't know if you can see this, but that is a capacitor there, and it says 16 volts on it. This one says 25 volts. So I think there's 20 volts RMS coming in to the board, but that's too high. It probably should be about 12 volts or something like that. So that could be the origin as to why this failed. That's just a guess. Now of course this toaster failed just outside the warranty, and I stuck it up in the loft and it's been there ever since. I just thought I'd get it down and see if I could fix it. So let's try replacing this resistor. Now if I look at the colours, that's orange, white, black, gold. That corresponds, I believe, to 39 ohms. Now, I don't have any of those resistors, but I do have a 47 ohm resistor. Now obviously it's not going to be at the same power rating as one of these. This is more for hobby electronics, but if we put it in, at least we can prove that that's the fault. So I'm going to do that. So that's the new component soldered in here. So now let's connect it back up and see if the toaster works. So I've reconnected the board now with the resistor in place. So right, got my gloves back on. Let's plug it in. Turn on. Wait a minute. Let's remove this rubber. Turn on. And let's see what happens. And look at that. Some lights have come on. Yes, works. I knew it was going to work because I've actually done this fix before. I was just taking you through the steps that led me to it. So amazingly, it was a resistor which was at fault. So obviously now what I need to do is get a proper replacement for that resistor that is at a sufficient power rating or a similar power rating to this one, which I don't know what it is. Put it all together and then I'll demonstrate the toaster working, hopefully. Now look at that, I've got it back together, gave it a bit of a clean, and now it's time to test it. But before I do that, oh by the way, when I had to put the knob back on, you can see where I had to cut that off. So it came out really nice, apart from the fact of that knob. But I put the two pieces together and taped it together. Gave it a bit of a clean and a polish. As you can see, it's come out really nice. One reason for that is it's hardly been used because, as I said, after a year it failed. And let's now give it a spin and see if it works. And honestly now, I haven't tried it yet, so this is a real test. Here we go. I've got a couple of slices of bread here. Let's plug it in. Turn it on. I'll just put this to the middle. I've no idea what setting it should be. And let's give it a spin. It's on. There's a light lit. I'm not sure what that is. Yes! Look at that. Oh! Perfect. Can't believe it. Fantastic. That's it.